A satellite just photographed something that shouldn't exist. Buried in the ice of Antarctica, thousands of miles from any living creature, radar data revealed the unmistakable shape of a hummingbird. Wings spread, head tilted, frozen into one of the most lifeless places on Earth. It's not real, not an aircraft, not a hidden structure, and that's exactly why scientists couldn't stop looking at it. Because the satellite that captured this doesn't work like any camera you know. No sunlight needed, no clouds to block it. It sees through snow, through ice, through darkness that blinds every other satellite on Earth. So what did it actually find under the ice? And why does NASA call it one of the most important machines ever launched? That's what you're about to find out. At first glance, it looks impossible. A tiny hummingbird frozen into the heart of Antarctica, thousands of miles from the nearest tree, flower, or habitat where a bird like this could ever exist. When the image started circulating, the questions came fast. Was it edited? A hidden structure under the ice? Some kind of cover-up the internet wasn't supposed to see? Here's the strange part. Even scientists took a second look before they had an answer. Because what you're looking at isn't a bird, it's a mountain. Specifically, it's called a nunatak, an isolated rocky peak that rises above the ice sheet while everything around it stays buried under kilometers of frozen weight. For thousands of years, Antarctica's glaciers have moved around this exposed rock like a river frozen in slow motion. As the ice squeezes past, it fractures. Enormous cracks called crevasses spreading across the surface. From the ground, those cracks look random. From hundreds of miles above, they don't. The radar patterns around this mountain lined up into something the human brain instantly recognizes. Wings, a head, a beak, a hummingbird carved by ice instead of feathers. Nothing about it was created. Nothing was hidden. There's no lost wildlife surviving in Antarctica. It's called pareidolia, the brain's habit of finding familiar shapes in random patterns, the same reason you see faces in clouds or animals in rock formations. But here's what makes this case different from every other optical illusion you've ever seen. The hummingbird isn't the discovery. How scientists were able to see it in the first place, that's the discovery. Because this wasn't captured by an ordinary camera. No astronaut pointed a lens at Antarctica. No plane flew overhead. If this mission had relied on a traditional optical camera, this image would never have existed. It came from one of the most advanced Earth observation systems ever built, one that doesn't need sunlight, doesn't care about clouds, and keeps working in conditions that shut down almost every other satellite on Earth. Which raises the real question. If this satellite isn't taking normal photographs, what exactly is it seeing? And what else has it already found that nobody's talking about yet? To understand why a mountain could look like a bird, we need to understand the machine that made the invisible visible. Imagine trying to explore a city in the middle of the night during a powerful storm. The streets disappear, the buildings vanish behind thick cloud. To an ordinary camera, the entire landscape becomes useless. Now imagine switching on a light powerful enough to cut through all of it. Not visible light, but invisible radio waves. Suddenly, darkness doesn't matter, clouds don't matter, even heavy snowfall barely slows it down. That's essentially how this satellite works. It's called NISAR, short for the NASA-ISRO Synthetic Aperture Radar mission, and its job was never to take beautiful photographs of Earth. Its job is to measure change. Instead of recording colors, NISAR sends powerful radar pulses down to Earth's surface over and over again. Every pulse bounces back differently depending on what it hits. Smooth ice reflects one way, rough terrain reflects another. Rock, water, cracked glaciers, every surface leaves a different signature. But here's the question almost nobody asks. If it's not a camera, how does it turn radio waves into something we can actually see? Computers take millions of those returning echoes and transform them into detailed radar maps. Maps that reveal features human eyes could never detect on their own. This is why the Hummingbird was never a photograph. It was a scientific map, built entirely from reflected energy. Every color meant something. Purple marked smoother ice. Green revealed rougher, fractured surfaces. Bright white showed where signals overlapped, exposing tiny differences in the landscape most people would never notice. To most viewers online, it looked like digital art. To glaciologists, it was a fingerprint, one of the most detailed ever captured of that stretch of Antarctica. And this is where NISAR stops being impressive and starts being important. Because unlike ordinary satellites that wait for clear skies, radar keeps working through clouds, fog, smoke, rain, and total darkness. It can return to the exact same location again and again, comparing one scan to the next. At first, the differences look meaningless. A glacier shifts by a few centimeters. A mountainside moves a fraction of an inch. Nothing dramatic, nothing visible to the naked eye. But scientists aren't watching for what's visible. They're watching for what happens next. Over weeks, months, years. Those tiny, invisible movements start telling a story no human observer could ever piece together alone. Scientists can watch a glacier accelerate long before it begins to collapse. They can measure land sinking after groundwater is drained away. They can catch a slow-moving landslide months before an entire hillside gives way. They can even detect subtle shifts caused by earthquakes and volcanic activity, sometimes across entire regions, all at once. In other words, NISAR isn't taking snapshots of Earth. It's building a time lapse of a planet that never stops moving. And Antarctica might be exactly where that ability matters most. Because underneath that endless white surface lies a world that's stayed hidden for millions of years. Buried mountains, ancient lakes sealed in darkness, rivers of ice moving faster than anyone predicted. If NISAR can already reveal a mountain shaped like a hummingbird from orbit, what else has it already found beneath the ice that scientists haven't announced yet? From space, Antarctica looks almost lifeless, an endless sheet of white stretching farther than the eye can see. No forests, no cities, no rivers cutting across the land, just ice. At least, that's what it looks like from the outside. The truth is far stranger. Beneath that frozen surface lies an entire world almost no human has ever seen. Imagine stripping away every layer of ice in an instant. What's underneath isn't a flat sheet of frozen land. It's towering mountain ranges, deep valleys, massive canyons, volcanoes, hundreds of hidden lakes sealed beneath the ice for hundreds of thousands, maybe millions kilometers. Some of those lakes are larger than entire cities. Others haven't seen sunlight since long before humans existed. It's one of the most isolated environments on Earth, and yet it isn't standing still. Every single day, Antarctica shifts, slowly, almost silently, but constantly. The ice sheet isn't a frozen block sitting still. It's a river of ice, spreading outward under its own weight. Some glaciers creep forward a few feet a year. Others move several meters, every single day. From the ground, that motion is invisible. From orbit, NISAR can measure changes so small they'd normally go completely unnoticed. A glacier shifts, a crack widens, an ice shelf starts to bend. Individually, none of that seems like much. Together, it's telling scientists something they didn't expect. Antarctica is changing faster than many early climate models predicted. Glaciers once considered stable are now speeding up. Ice shelves that have held back massive glaciers for centuries are showing new signs of stress. And when those floating shelves weaken, they stop acting like natural dams. The glaciers behind them start flowing toward the ocean much faster. Here's why that matters, wherever you're watching this from. Antarctica stores nearly 70% of Earth's fresh water, locked away as ice. Even a small fraction of that reaching the ocean could reshape coastlines around the world. But predicting that future is brutally difficult, not because scientists lack computers, not because they lack satellites, because the warning signs often begin long before anyone can actually see them. A tiny crack today can become a massive fracture years later. A glacier moving slightly faster this month might not become unstable for decades. Without precise measurement, those signs are almost invisible. That's exactly why a mission like NISAR matters. Instead of waiting for a dramatic collapse, scientists can watch the earliest stages of change as they happen, like checking a bridge for microscopic cracks, long before it ever fails. The goal was never just to observe disasters after they happen. It's to understand exactly how they begin. And Antarctica isn't the only place this technology is making a difference, because the same radar watching these glaciers can also detect earthquakes, track landslides, measure sinking cities, monitor forests, and catch subtle shifts in Earth's crust that the people living above them never even feel. Suddenly, the Hummingbird image starts to seem a lot less important. It was never the discovery, it was the demonstration. Proof that this satellite can see patterns hidden across the entire planet. So if it can already detect changes this small in the most remote place on Earth, and what happens when it turns its attention to places where millions of people actually live? Imagine waking up one morning to find out the ground beneath your city has been sinking. Not by inches overnight, by amounts so small no person could ever feel them. A fraction of a millimeter today, another fraction tomorrow, year after year. Individually, those movements mean nothing. Together, they can threaten roads, bridges, railways, pipelines, even entire neighborhoods. Until recently, scientists often didn't catch these changes until the damage had already started. Now, they might be able to watch it happen in real time. And that's exactly where NISAR stops being an Antarctic mission and becomes something much bigger. Its radar isn't fixed on one continent. It's built to scan nearly the entire planet, returning to the same locations again and again, building an extraordinarily detailed record of how Earth is changing. That means one satellite can monitor thousands of events happening at the same time all over the globe. A slow-moving landslide in the mountains, a volcano whose surface begins to swell before an eruption, farmland gradually drying out as groundwater disappears beneath it, coastal wetlands quietly shrinking, even the ground shifting after a powerful earthquake hundreds of miles wide. Most of these changes are completely invisible to the naked eye, but they leave fingerprints in the radar data, fingerprints that often show up long before the consequences become obvious. Take earthquakes. No satellite can predict exactly when one will strike. That's still beyond today's science. But after a major quake, radar can compare images from before and after, revealing exactly how the ground shifted, sometimes just a few centimeters, across hundreds of miles. That data helps scientists understand what happened underground and improve the models used to prepare for the next one. The same principle applies to volcanoes. Before magma ever reaches the surface, it can slowly push the ground upward. The movement is often so small that people living nearby never notice it. Radar satellites can catch it anyway, with a level of precision that gives emergency agencies a critical extra piece of the puzzle. Then there are landslides. Some of the deadliest ones in history didn't strike without warning at all. In many cases, the slope had already started moving weeks, sometimes months, beforehand. The motion was so slow, so subtle, that no one on the ground could detect it without specialized instruments. If satellites can catch those shifts early enough, local authorities may have real time to inspect the area, monitor the risk, and warn people before it's too late. That's why scientists don't think of NISAR as just another satellite. They think of it as a global measuring system, a machine that continuously checks Earth's pulse, not once a year, not once a month, over and over, building a long-term record of changes that would otherwise stay completely invisible. And maybe the most remarkable part is this: the Hummingbird image that captured the world's attention was never the mission's goal. It was a beautiful accident. While millions of people online saw the outline of a bird, scientists saw proof the radar was working exactly as designed. Every crack, every ridge, every subtle texture in the ice, recorded in extraordinary detail. If a single image can reveal that much about one isolated mountain, what could years of continuous observation reveal about the entire planet? When people think about space exploration, they usually imagine distant galaxies, alien worlds, rockets heading toward Mars. But sometimes the most important mission in space isn't looking outward, it's looking back at us. Because despite centuries of exploration, our own planet still holds mysteries we haven't solved. We've mapped the moon in extraordinary detail, photographed galaxies billions of light years away, landed robots on Mars, and yet large parts of Earth are still changing faster than we can fully track. That's why missions like NISAR represent something different. Instead of chasing one single discovery, the satellite is built to collect an endless stream of observations, day after day, year after year, which means the real breakthroughs won't happen this month, or even this year. They'll emerge only after scientists compare thousands of radar scans collected over time. A glacier that gradually speeds up, a mountain slope that starts to creep, a coastline retreating a few centimeters each season. Individually, small. Together, they reveal how an entire planet is evolving, something no generation before us has ever been able to track with this kind of consistency. And this is where it gets genuinely interesting, because humans alone can't process this much data. Modern satellites generate far more information than researchers could ever examine by hand. So artificial intelligence has started stepping in, comparing millions of radar measurements, hunting for tiny patterns a human eye would miss entirely. Not because the machine understands Earth, because it's exceptionally good at noticing what changed. That partnership, satellites, scientists, and AI working together, could reshape how we study this planet over the next few decades. Researchers may catch glaciers destabilizing earlier than ever, identify land sinking from groundwater loss before it becomes a crisis, improve flood models, track forests recovering after wildfires, understand how earthquakes reshape the crust beneath our feet. None of those discoveries will come from one dramatic image. They'll come from patience, from years of quiet observation, from noticing the smallest changes before they become the biggest headlines. And maybe that's the real lesson hiding inside Antarctica's so-called hummingbird. It was never extraordinary because it looked like a bird. It was extraordinary because it proved just how much detail modern radar can reveal. So if one mountain produced an image that captured the world's imagination, what other patterns are still waiting? Beneath the ice, inside remote forests, across deserts, deep within a planet that never stops shifting. Right now, nobody knows. And that's exactly what makes this mission worth watching. The hummingbird in Antarctica was never a mystery waiting to be solved. It was a reminder that our brains are wired to find familiar shapes, even in the most unfamiliar places on Earth. But while millions of people saw the outline of a tiny bird, scientists saw something bigger. They saw a satellite performing exactly as it was built to, revealing details that no ordinary camera could ever capture. That single image tells a much larger story, a story about technology that can see through clouds, work in total darkness, and monitor the most remote corners of Earth with a level of precision we've never had before. As glaciers shift, as coastlines evolve, as natural hazards become easier to track before they strike. Missions like NISAR will keep orbiting quietly above us, recording changes too small for human eyes to ever notice on their own. Most of its biggest discoveries haven't happened yet. Some may take years to fully understand. Others could completely change how we prepare for what's coming. And maybe that's the most remarkable part of all. Sometimes the greatest discovery isn't finding something that never existed. It's finally gaining the ability to see what was there all along. Because the next world-changing discovery might not come from deep space. It might be hiding beneath the ice of our own planet, waiting for the next radar pulse to reveal it.